If you flip to the back page of your notes, the very back page looks like this. The very back page has a front and a back, and the front side is going to be what we're going to talk about today, and then later on we'll do the back side. Some people say that this really helps them kind of understand fully the, graphing polynomials and finding roots of polynomials. See how it works for you. We start with just this. Y equals x would be a type of first degree polynomial. Its general graph looks like this. I'll move a little bit quickly because we got about 22 minutes before bell goes, and I know we got snow and everything. So second degree, what does that look like? Yeah, there you go. Third degree, something like that. Fourth degree, something like that. Fifth degree, something like that. Yep. So let's make some conjectures about the shapes. It doesn't mean that they all look like that. There's an infinite number of different graphs for each one that you see. But just look at this right here, okay? Notice that the parabola has a bump. How many bumps does the line have? None, and it's first degree. How many bumps does the parabola have? And it is second degree. How many bumps does the cubic have? And it's third degree. How many bumps does the quartic have? And it's fourth degree. How many bumps does the quintic have? 4, and it's fifth degree. So, local extrema of a polynomial. These are called local extremes. Local mins or local maxes. If it goes up, it's a max. If it goes down, it's a min. Given a polynomial of degree n, there are at most, how many? If the degree is n, how many bumps will it have? N minus 1. So the bumps are mins or maxes, local minimums, local maximums, as we call them. All right. So, also notice they start in different directions, don't they? Some of them start down, some of them start up, but they all finish up. Unless they're negative, they're all going to finish down. I think I might watch Born Identity tonight. I love that movie. No, I'm an old Matt Damon, Jason Bourne kind of guy. I love the originals. Love. Well, I assume that there was a new one if you said. Okay. So look at these. They all finish down, don't they? Can you help me understand how I can predict whether something is going to, if it's going to finish up if it's positive, it's going to finish down if it's negative, right? Can you tell me something about which direction it's going to start? If it's odd, starts opposite of where it finishes. If it's even, it starts the same as it finishes, right? Do you see that? That's important. If you can remember that, and we'll write it down again on Monday, if you can remember that odd functions start and end in different directions, and even functions start and end in the same direction, that's going to help you out as we graph them. Turn to your front page of notes. I'm very honest with you guys about things I do well and things I don't do well. One thing I'm horrible at is organization, and I lose stuff in my classroom all the time, and I don't always write the assignments on the board. But I do try to give this to you, again, at the front of your notes. You can write your assignments there all the time. It's a special spot for you, so in case you're not good with the planner, I never was, you can write them right there, okay? Sketch a graph of the following polynomials that are already factored. So I taught you how to graph parabolas in the last unit, correct? And these parabolas were not factored at that time. We put them into vertex form. We looked at them in standard form. We're going to look at some polynomials that are already factored, and we're going to graph them. First thing I'm going to decide is what degree is this polynomial. If I multiply these x's out, do I get first, second, third, fourth? What do I get? This is a second degree polynomial. When I multiply it out, will I get a positive x squared or a negative x squared? I will get a positive x squared, okay? A positive x squared. So therefore, it's going to finish up. It will start up or down. It will start up because it's an even degree. It will start and end in the same direction. Okay, so we're going to draw a little graph here. And in this unit, we're so concerned about where it crosses the x-axis. That's our primary concern. So what I want to do is I want to find, and I'm going to use some different words now, I want to find the solutions, or the roots, or the zeros, or the x-intercepts of the function. For example, what number would give you 0 here? 2. So 2 and negative 3 are the solutions, or the zeros, or the roots, or the x-intercepts. All of those phrases are synonymous in this scenario. These are my solutions. I mark them out. 1, 2, 1, 2, 3. We're just going to make a quick sketch. They go through those spots. You told me it starts up and it finishes up. So I'm going to draw a graph that starts up and finishes up. And there you have it. We'll try a few of these examples so you can see how it goes. What is the degree of this one? Very good. So your third degree. And when you multiply it out, is it going to be a positive x to the third or a negative x to the third? A negative x to the third. Okay? So, am I going to finish up or finish down? Finish down because it's negative. Why start up or start down? Up because it's opposite of where you finish because it's an odd degree. Okay? What are my solutions here? Negative 4. So mark it out. Told me I start up. I'm going to go through negative 4, through 1, and through 5. Do we know how high or low to make the bumps? We don't. That's where calculus comes in. Okay? In calculus, we do find those spots. Number 3, first, second, third, fourth degree. What is it? Third. Positive or negative? Positive. Finish up, finish down. Finishes up. Start up or start down? Starts down. What are my solutions? What are my zeros? You told me that it's going to start down and finish up, and it's going to go through those spots. Kind of takes a little bit of being an artist to draw some of these, but not so ridiculous. I would say that's much better than some people's I see. So sometimes you just try to make it work to the best of your ability. I get the idea. I can understand it. All right. Number 4. What makes number 4 different? Would you agree it's negative x times x plus 4 times x plus 4? Okay, so that means my solutions are 0, negative 4, and... Oh, what do I do if the same solution happens twice? We're going to flip back to our previous page that we were at to take our notes, and that'll be our last time on that page. We need to understand what to do in that situation. We have things in mathematics called single roots, double roots, triple roots, quadruple roots, all sorts of stuff. And here's what happens. If you have a single root, it just passes through the solution on the x-axis, just like we've drawn so far. But suppose that the root or the solution is right there. What happens is the graph comes down and touches tangent at that spot. So it doesn't pass through, it touches it and it bounces off. Suppose it's a triple root. It will come up and touch tangent, but then it passes through. So as you look at this graph right here, this is a 9th degree polynomial. It's very exciting to see. Can you tell me, is this going to be a single, double, or triple root right here? That's a triple. Very good. How about this one? Double. This one? Single. And this one? So this is a nice graphic organizer to kind of keep in your brain what the behaviors of those functions are at different spots. Now that we know what double roots do, we can go ahead and graph the previous function. So let's flip back to that page, and I'm going to draw my graph. Is this going to be first degree, second degree, third degree? Third degree. And is it going to be positive or negative? It's going to be negative. So will it finish down or finish up? It's going to finish down because it's negative. And will it start up or finish, or start up or start down? It's going to start up because it's odd. It's opposite of where it finishes. So I'm going to mark these out. I'm going to mark a -4, and I'm going to mark 0, okay? Those are the two spots where it's going to come in contact with the x-axis. You told me it's going to start up. Now, what happens at -4? Do I pass through? I touch tangent and bounce off. What happens at 0? Do I pass through or do I touch tangent? I just pass through, so looks like that. And that's actually a really accurate graph. I mean, the bump might go higher, but if you were to graph that on your, if you were to type exactly that in your calculator, we don't have a lot of time to do that, but it would look pretty good, okay? It's amazing how quickly you can come up with these graphs. So it's nice because when you bring this home over Thanksgiving, you start to do some of the work. Grandma and grandpa and aunts and uncles will be like, wow, you must be really smart if you're doing that stuff. It just looks crazy like. And then you tell them the news that they were waiting for. I am crazy. All right. Number 5, what degree? 4th degree, very good. Is it going to be positive or negative? It's going to be negative. Why? Because there's a negative x hiding on the inside. So if you're going to multiply it all out, you would get a negative x to the 4th. Is it going to finish up or finish down? It's going to finish down. If it's negative, it will always finish down. If it's positive, it will always finish up. Once you determine that, you determine where it starts. Even powers start and finish the same direction. Odd powers start and finish opposite directions. Let's find our solutions. What do you plug in to make 0? 5, -3, +3. So I'm going to mark those out. -5, -3, 3, +5. Are there any double roots? No, all single roots. So I'm going to start down. I'm going to pass through. Is that pretty? I think it's beautiful. Oh, the weather outside is frightful. 5 is so delightful. You think that on the microphone they're going to think it's creepy that I said beautiful? It is beautiful. People don't watch, like if you're not serious about mathematics on YouTube, people will just turn you right off. They're like, I need somebody who's really going to embrace mathematics. So that's why they tune in. My 37,000 views, they want to hear how beautiful I think mathematics is. Yeah, I think most of them are probably like watch for 3 seconds and be like, okay, I'm done. I just do this for you guys. Like all of our kids are gone today. It's a real headache for me. Then when they come back on Monday, like, I don't know what to do. At least half of them will have watched the video and they'll feel like they know what's going on. Here's the tough thing though. Do they have the notes? But could they still take notes? But that's what will probably happen. They're like, oh, I don't have notes. What's the point? Well, you could still write them down. Okay. What degree? Fifth. Very good. Positive or negative? Positive. Finish up, finish down. Finish up. Start up or start down? Down. Excellent. What are my solutions? 0, 0, 0. 4 and 4. Oh boy. This is uncharted territory. We have not come across a double root and a triple root, have we? Okay. Oh, Alex, you want to come up and draw it? All right, come on and do it. I believe in him. Do you guys believe in him? All right, give him a round of applause. He's going to do it. Alex, Alex, Alex. Alex from Target. Okay. Oh, Alex from McDonald's. All right. Okay, it's positive, so it finishes up. Since it's fifth degree, it starts opposite of where it finishes. Yes, this is excellent. Now, Alex, I would give you full credit for this on the test. I would just encourage you guys, as I practice more, here's how I would try to draw the graph. So no, I'm not trying to show you up. I'm just saying that, you know, with a little bit more practice, that's kind of how I would try to sketch a little bit more. Try and make your curves nice and smooth, not very erratic, okay? Because, no, it's actually, we are actually, guys, I showed you the barcode function, right? Okay. So, I said nice functions. These are all nice. They're not like the barcode function, okay? Let's try 2 more, and then I'll show you what I want you to do over break. Whoa, what happened there? Oh, Maddie scrolled. Maddie, how do I get the page back? Oh, there it is. Okay. Yeah, you don't know what you're doing. Okay, all right. What degree is this one? No, fourth. Positive or negative? Negative. Finish up, finish down. Finish down, very good. And start up, start down. Down, because it's even, it will start and end in the same direction. Okay? What's the solution? 5, -1, -1, 2. So I plot those. -1, 2, and 5. You don't even have to space them correctly. I'm not that concerned. Just make it so you can draw it nice and easy. Double root at -1. So what's going to happen here? Do I pass through? U-turn, sure. There you go. How about at 2? Pass through. Do one more. What's the degree of number 8? Fifth degree. Negative. Finish up, finish down. Finish down, very good. And start up, start down. Start up. What is my solution here? 0, 0, 0. -2, 4. Okay, you told me I'm starting up. What happens at -2? Pass through. Then what happens at 0? Does kind of that wacky behavior, huh? Now, sometimes people wonder at that point, what do I do next? Well, you know that you just passed through 4. It's a single root, but always keep this in mind as well. If it's 5th degree, will it start and end in the same direction or opposite direction? So you're going to end going down. So just make sure that happens as you draw through there. So you get that kind of shape. So what I want you to do is 9 through 18 on your notes. So I'm not giving you really an assignment, but it would be helpful if you could just quick sketch 9 through 18 in your notes. You might solidify your learning so when we come back, we can save some time. We'll go over a little bit of this again, but try to get 9 through 18 done, and that's it, okay? All right? Enjoy your turkey weekend. Make sure Miss Nelson's room and say gobble gobble, okay? She would love that. She misses the turkey day with you guys, so.